So are we good? Number 10. Okay. I don't have a paper. Can I see that, please? Okay, so number 10. Okay. Okay, so for number 10, it's talking about this shark. Okay, so the information you're given. Okay, 8450 kilograms per meter per second is a what? 8450 kilograms per meter per second is a what? 8450 kilograms per meter per second is a what? Is a momentum. Okay? And when we continue to read the problem, it says struck with a velocity. So what does that mean? It's struck with a velocity of 10.20 meters per second. Okay, so even if we didn't know whether it was final or initial, since it's meters per second, we know that it's a velocity of some sort, 10.20 meters per second. Okay, and what else do we know in the problem? Okay, is that it? Okay, acceleration, 2.95 meters per second squared. Okay, so again, when we're looking at this variable, we know it's a velocity. We don't know, is it final or is it an initial one, but it goes on to talk and ask, how fast was it moving initially? So it's talking about fast or speed and initially, so that means we're looking for which variable? Okay, we're looking for the initial velocity. Therefore, that makes this the final velocity for two reasons. One, we're looking for the initial, and it says it struck with that speed, and we know that if you're making impact with an object, what is that telling you? That velocity is what? Is it final or initial? If it's making contact, it's final velocity, so it has to be. So even if we weren't sure, since it said it struck with this velocity, we know that it's a final velocity. Is there anything else we're looking for in this problem? Mass. Yeah. Okay. So with that, with the information provided, what might be your next variable you want to solve for? Can we solve for the mass? Sure. Okay. So how would we go about solving for the mass? How would we go about solving for the mass? Now, I can just go through and just say, this is what you do, this is what you do, and then we're sitting there, we're probably nodding our head yes, and then, in my opinion, we don't learn anything that way. Or is that what you prefer I'd rather do? Just work through the problem and say, this is what you got to do. What do you think is more beneficial for you? The first choice or the second one? The first one is where we work on it together. The second one, I just go through and just tell you what to do. We in agreement, or you? Yeah? Okay. So how are we going to solve for mass with this information given? Okay? So remember, you have this formula. Okay? So we added this one last week. All right? So we also have the V equals D over T, and then acceleration equals VF minus VI divided by T. All right, so with that, you correctly said 8450 equals, what's on the right-hand side? And, yeah, 10.20 V, oh, excuse me. not VF. Okay? So with that, how do we get that variable all by itself? Okay, divide by 10.20. So the mass then equals, I don't know, is it 820 something? 820. So wherever, okay? 820 kilograms. You all would be able, or physically able to punch that in your calculator. This divided by 10.2, okay, gives you somewhere around 820, okay? Specifically, okay, 8450 divided by 10.2, okay, 828 then, okay? Just in case someone's watching later and just says, well, why are you just saying around 820? 828.43. Okay. So that solves that part of the problem. Okay? How are we going to solve for that initial velocity? Well, we have the information that we need to know, or we wrote it down. So with what we have here, with these three variables, remember there's 4 of them in that equation. We've got 3 of them, so we can solve for that. Okay? So what is it that we're going to do here? Well, do what the formula tells you to do. Where does 10.20 go in this equation? Yeah, right side, top or bottom? There it is, right side on the top, 10.20. What's left over on the right side? Minus VI and 2.12. All of that is equal to what? 2.95. Okay? So we don't need this information anymore. Go ahead and erase all of this. Okay. Using your algebraic skills, what is the next thing you're probably going to do? Get rid of what? Yeah, when you cross multiply, what are you getting rid of? Yeah. Well, it's the same thing. It's just saying, you're saying the same thing, but in a different way. In other words, ferrous instead of iron. Saying the same thing, just in a different language. Okay? So you're saying the denominator by cross multiplying. Yeah, fraction. We're saying the same thing. So when we do that, notice we haven't changed the values. So what happens when we take 2.95 times 2.12? 6.25. Okay, so that equals, what's on the right hand side now? Well, what's 1 times 10.20? Okay, and what do we have left over yet? Minus VI. Okay, so notice with that variable, we're not dividing anything, we're not multiplying anything like we are up here. Here we got a multiplication process. So you undo multiplication by dividing, by division. Right. So how do we get this subtraction or this value from a positive 10.20 on the right side to the left-hand side? Right. So if this is a positive value, we need to subtract these two, minus 10.20. But we're doing that on the right side. What do we have to do to the left? Okay, they're gone, and we subtract these two. What do we get? Okay. And then that equals what's on the right-hand side still? Negative VI. But we had said that all velocities are what? Well, we got a negative initial velocity. But the left-hand side of the equation is still saying what? That's also negative. Okay? So we get rid of all of this. We got negative 3.95 equals negative VI. Either divide or multiply by what number? A little more specific. Not just 1, because then you're just still going to get the same thing. Negative 1. Okay? You either multiply through by negative 1, and you don't have to show that because all you're doing is just changing the values on that. Whether you multiply by negative 1 or divide by negative 1, you're changing that negative initial velocity to a positive value. Okay. Any other questions? And it's probably just a simple algebraic mistake. Okay? We say the same things when it comes to mistakes. Well, for one, we're going to make them. It's easy to do. But when it comes to these mistakes, what 2 things do we always say? Or have we always said? Do you think? Well, 1, let's try not to repeat them. And 2, try to learn from them. Okay? At least that's the idea. Can we erase this problem? Okay. Is there anything else that was on your exam that, I just didn't quite get? Some of you, I got to make sure with that baseball example, if I'm not mistaken, I thought that problem was still different on both pages, but it's the same problem on both. Because there's 2 forms of this exam. Okay? You might not realize that. All the questions are the same, but the values are different for the variables. In other words, when it comes to that crocodile jumping out of the water, on one form the velocity was 13.31 meters per second, and on the other form it was 16.61 meters per second. Okay? So in certain cases, some of you needed to answer and say, well, nope, the wildebeest got away, or nope, the croc grabbed the wildebeest and pulled him into the water. Poor thing. I don't know. That's just a scenario. Can I do what? Okay, so when it comes to that, I believe David is safe because it says solve for time and say which one gets home first. Okay, so the best way to do that, I think, okay, is we've got the ball, okay, and we've got David, because he's tagging up from third and trying to run home. Okay, so when this ball was caught, it's, is it 199 no. It gives it in feet, but also meters. So when that ball is caught in left center, what's the distance? That's this one. 118.99, okay? Meters, okay? So how fast is that ball being thrown from left center? Isn't it like 40-some meters per second? No, 24, okay. 22 point... just one person, please. 0.20. Okay. So we need to solve for the time. Okay? Well, David, on the other hand, has this far to go, and how fast is he running? Okay, so we also need to solve for the time. Okay, so doing what the formula tells you to do, which is say 22.20 okay, you could cross multiply again if you wanted to. You're just showing that over 1. What's 1 times 118? Okay, so we still have 118.99. What is a number times a variable? The number and the variable, 22.20t. So here we're multiplying. How do we undo that multiplication? We're going to divide. So 118 divided by 22.20, 5.36 seconds. Time equals 5.36 seconds. Okay? So when we look at this scenario, we're going to do the same thing. Okay? 5.95 equals 27.4 over t. 1 times 27.4, you agree, it gives you the same thing, right? Okay? So we're going to divide 27.4 divided by 5.95. And we get 4.60 seconds. So who gets home first? David does. Now in some of yours, it may have been counted wrong. Some of them I caught, but maybe not until later on. Is that the case? Did anyone have written David gets home first and was counted wrong? Nobody? And maybe I went back through and made that correction. Now, chances are, when you were looking at this problem, is this one difficult? Maybe. It's probably because there's too much terminology and the problem may have been written too long. But in other words, to describe that and what's actually happening, that's where we're at, where we're going with that. Any other questions on there? Okay, I will collect them then, please. Okay, thank you. Thank you. Thank you. Thank you. Thank you. Okay. Okay, thank you. Is this everybody? Okay. Because you may see these problems again at semester time. That's one of the aspects that, just like in junior high science, you probably had a semester exam. You also have one in here as well. But one of the things to keep in mind is that this information continually builds upon top of one another. Okay? So let's go ahead and go over this problem. So you chose to write it down. The next thing you should do is what? So what do we know in this problem? Mass is what? Okay, what else do we know? Okay. But when we look at that, meters per second, which velocity is that? It's the initial velocity. Okay. 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 So, is there anything else that we know in that problem? No, there is not. But what are we ultimately looking for? Okay, so when we solve for force, we need to know two variables. They are what and what? Okay, well, we got the mass, but what's the problem with that? We don't have the acceleration. Okay, so do we have enough information to solve for the acceleration? Yes, we do. Okay, so how do we go about doing that? Okay, so notice we don't have to keep looking up there. We've got 7.18. Okay, according to this formula, 7.18 minus our initial velocity, which is 4.18. And that's all over what? 2.10. And that equals our acceleration. Okay. So, and for the most part, you know, if you really need to be specific, we can put that in parentheses, but we've all been pretty good about that, just knowing we need to subtract first, then divide. Okay. So, with that, I think we get what? 3 over 2.10? So acceleration equals 3 divided by 2.10. Subtracting these two gives us 3 over 2.10, which then ultimately gives us what for an acceleration? Okay? Okay, so that's our acceleration. So now that we found the acceleration, what can we do next? Find the force. And to do that, notice accelerations measured in meters per second squared. Their mass is in kilograms. We've got our kilograms. We've got our meters per second squared. The formula tells you to multiply the two. That gives you your answer. So what we see happening is maybe this is based off of, maybe it's a muddy spring of some sort, and you need to pull a rack full of hay down through a patch here and make a sharp turn. Well, upon doing that, maybe through the mud or the ice, maybe it slips, okay? And going from this speed, saying, oh geez, we got to push the clutch in, we're going to try to slow down. Well, we did that, but then we still struck that post moving at 1.42 meters per second squared, which maybe is or isn't bad, but that's the post that holds the gate up, and then now the gate's laying on the ground all mangled and torn apart, and now you need to dig a new post, and then you need to get a new gate, and maybe that's happened before. Maybe yes, maybe no. But sometimes when we look at the spring, I'm sure you have observed some muddy driveways, yards. It's just all part of growing up in South Dakota. Okay, so how do we solve for the force again? We're going to take this 1.42 times what? 12,250. So 12,250 times 1.42, and we get 17,395. Okay, so again, what we did, 12,250 times 1.42 multiplying those two numbers gives you 17,395. How do we label forces? (95) newtons. All forces are labeled in newtons. Okay. I didn't anticipate going that long, but that's okay. So, new problems, okay, that deal with force, but it's based off of information that we've already learned. So that's what I mean. It continually builds upon itself on what's expected of you, okay? Because tomorrow we're going to start talking about pressure, okay? Which in certain cases, if you're a Minnesota fan, well, maybe came on the short end of the stick yesterday, but that's just the way it goes. Or if you're a Green Bay fan, you also came up on the short end of the stick, and that's just certainly much better than a loss, but so it goes. Okay, we'll continue with this tomorrow.